Sure.
So it's a
So,
collaborative project that we've been working on all semester. This is sort of like a new thing. Amal and Justin are both students. Amal just graduated. And we hope that our demos will work, but as with any demos, you never know. But, you know, people have been prompting us to sort of look into this. What would it take to teach with these materials in other ways? And so we sort of just started experimenting, like what would be other ways we could, you know, work with these materials. And so I'm going to let Amal start off, but I might jump in from time to time.
Yeah, we'll actually have Justin start off.
Oh, Justin, you go.
okay, awesome. So, hello everyone. Welcome once again to our data science workshop this year. And I hope you are having a great time so far. So my name is Justin, and joining me today in this presentation is my colleague Amal. And as Eric has said, we are both students and employees of the Global Adoption Team at Data Science Undergraduate Studies at Berkeley. And for the past semester, we have been exploring alternative options for teaching the Data 8 curriculum. And our team found the need to explore other cloud computing options as Data 8 is becoming increasingly popular among other institutions that seek to introduce their own data science curriculum. And to ensure that all labs, homeworks, and projects are distributed smoothly, we have adapted the Jupyter notebooks into various formats such as Google Colab and also Microsoft Deepnote to ensure instructors can distribute course content smoothly and via a platform that they prefer the most. So without further ado, let's get started. And next slide, please. Thank you. So the main goal of this project is to reduce the technical barriers that instructors face when teaching the data science at scale. And in the past, deploying our own Jupyter Hub for cloud computing has been a significant adoption barrier, especially for smaller institutions without the technical knowledge or like expertise. And Data 8 was first developed using Jupyter Hub, but it was pretty challenging to transfer all the course content smoothly using just Jupyter Hub. So this motivated us to look deeper into other platforms that are widely accessible, but yet is easy to use. And with this in mind, we will present 3 cloud computing options, along with solutions for course content delivery at scale. And all 3 of these pathways support auto-grading via AutoGrader, which is a code grader developed by the infrastructure team that checks the accuracy of our student solutions. And please be aware that the platforms we present today are not an exhaustive list, as these are just examples of delivering course content. And of course, you can always choose to teach locally, but standardizing student environments might be. These cloud computing platforms that we present today also allow instructors to distribute files at scale and grade assignments easier. And next slide, please. Awesome. So to give a quick review, all the assignments in Data 8 are a set of Jupyter notebooks that are mostly completed individually. And there are 3 main types of assignments. They consist of labs, which are created to confirm students' understanding on a particular topic covered in lecture. Second, there are homeworks, which check students' ability to utilize what they have learned with less guidance. And lastly, projects, which are significantly larger and cover a much wider range of content from the course. So for each assignment, there are 3 steps. We would first distribute a set of Jupyter notebooks to individual students. Students would then have to complete these assignments by filling in the missing parts of the code or typing a short paragraph-free response. And then they will be able to check their accuracy of their code using AutoGrader checks. And after a particular assignment is completed, the students would then submit their work as a PDF or IPyInB file to the grading system, where the AutoGrader would then check the correctness of their coding responses, but then the free responses would have to be graded by the course staff. And next slide, please. Now let's go through the platforms that we have explored that make content delivery easier. First, we have 2i2c, a nonprofit organization that designs, develops, and manages customized Jupyter hubs for communities in education and research. 2i2c collaborates with others in research and education, providing experience in interactive computing and the Jupyter ecosystem to build new technology that supports these communities. Next, we have Google Collaboratory, Google's free and accessible Jupyter Hub, Jupyter Notebook service that integrates with the Google Suite. When you create your own Google Colab notebook, they are stored in your Google Drive account. And this makes it easier to share your Google Colab notebooks with your coworkers or friends, allowing them to comment on your notebooks or even edit them. And last but not least, we have Deepnote, a platform developed by Microsoft that provides real-time collaboration and allows easy sharing and distribution. It comes with an interface where you can connect integrations such as GitHub with just a button. Now I will pass the time to Amal to explain to us how we use learning management systems and 2I2C.
Thanks, Justin. LMSs are different softwares that are used within different educational institutions that range from K-12 as well as secondary education, like universities and community colleges. So these three things that we're about to talk about, Canvas, creating a course website, and GitHub Codespaces, are different LMS softwares that can be integrated into an educational setting so that that can work well with other cloud platforms that Justin just talked about. So the first one is Canvas. Canvas is one of the most popular LMSs that are out there. And Canvas also has different seamless integrations which allow courses to run really smoothly. So for example, some use cases are where instructors can post course assignments on there, they can have quizzes on there, and they can show the students' grades on there. At the same time, on the student side, the students can easily get the course material, and they can also submit their homeworks or labs, and also take quizzes on there. It's one of the most widely used LMSs in the country right now, and it's used by all of the Ivy League universities, as well as many community colleges, as well as many UC schools. The second one is what the Data 8 website is based off of, which is creating a website off of like Google Sites. Google has created a product and has successfully been able to maintain it. It's called Google Sites, which allows you to create your own website. And the Data 8 website, at least, it's a Google site where it has different links to different course materials. And so that's really easy for students because it's completely accessible. It doesn't require any kind of login. It's available to everyone. And it's also really easy. So that's really helpful for institutions that don't necessarily have the tech help to be able to develop their own custom website. They can use Google Sites there. And then the third one is GitHub Codespaces. This is still in beta, but the idea of that is where they'll be able to integrate it with GitHub and be able to allow students or allow instructors to edit code or edit projects directly within their environment. Right now it's in beta, but like if you speak with them, you could get access to the beta version as well. So first, we're going to talk about 2I2C. We actually have a talk hosted by the 2I2C founders at this panel, or at this conference panel. So if you would like to learn more about 2I2C specifically, please feel free to go there. The goal of 2I2C is democratizing access to interactive computing, where traditionally for the past 3 or 4 years, whenever we had calls with different institutions, 4 years, UC schools, international schools, and community colleges, one of the biggest pain points that we saw was that that instructors might not have the tech help, both the capital or the actual resources, to be able to have their own Jupyter Hub. And so this could make adopting data science classes or any other kind of technical classes a little bit difficult. So 2I2C, a year and a half ago, where they started to host Jupyter notebooks and Jupyter environments into the cloud so that specific communities can use them. Now, this is really helpful because it's not just one large Jupyter hub. Rather, each user has their own independent hubs, which increases the ability and the seamlessness for the users as well as the professors. The really cool thing is that it's customizable, so it's not like a one-size-fit-all. Rather, you're able to tailor it based off of your needs. They recently, at least last year, they ran a pilot with a few community colleges, and that went very well. As Ksenia was talking about in the chat, there's also going to be at the expo on Thursday if you'd like to learn more about that. They also had a partnership with Cloud Bank, which where they had free credits for the community colleges that were in the pilot. And it really works well as you have more classes and as your classes get larger because of economies of scale, where you're able to get free computing from NSF. If you're interested, again, please feel free to come to the expo on Thursday. And there's Chris Holgraf in the chat as well, who's one of the founders. 2I2C also has really good open documentation. Their website's really easy to use, really easy to read. So feel free to go on there, pilot.2i2c.org. You can read through the documentation as well. Now I'll pass it on to Justin, who will talk about Google Colab.
Thank you, Amal. So, now let us dive deeper into Google Colab and how it helps us easily distribute Data 8 course content. So Google Colab is similar to a Jupyter notebook that can be shared and accessed by multiple users. It is pretty similar to how Google Docs keeps the functionality of Microsoft Word, but in an online collaborative environment. So each Google Colab notebook is shared in Google Drive, and administrators can share the notebook the same way as they would typically share a Google Doc, which is either by email or by link invitation. Using Google Colab is generally free, but Colab resources are not guaranteed and not unlimited. And the usage limit sometimes fluctuates, but it depends on the version of Python packages that is implemented. It also offers a pro tier of Google Colab, which has faster GPU, longer run times, and more memories. Next slide, please. So during our exploration, we found a few complications of using Google Colab for distributing course content. So for each one, we came up with solutions with which other Data 8 instructors and adopters might find useful in the future. So the first one is that Google Colab does not support file structures and paths, meaning that it is difficult to navigate to the correct file destination and access these contents in a specific location. But after doing some research, we solved this problem by directly mounting the entire user's Google Drive within the notebook. This allows users to access all the files within a folder in the Google Drive, including some of the CSVs, images, and links that supplement the assignment. And the second one is that Python environments on Google Colab does not last across sessions. And what I mean by that is all variables and installed packages will be lost every time a user refreshes the page. And at the same time, if you installed a package, let's say in the first Google Colab notebook, you would not be able to use it on a second notebook that has not installed the same package. And the solution to this is simply to reinstall packages in every single notebook that the course instructor is going to distribute. Note that the data science package, which is pretty important for Data 8, is automatically installed on Google Colab. And the third one is that the current version of Google Colab is below Python 3.7, which is incompatible with our latest version of AutoGrader. And to fix this problem, we had to install a less updated version of our grader. However, we have tested that all the grader cells function without error with the older version. Next slide, please. And here I've included some screenshots of one of the labs in Data 8 that we will be going through later in this session. Towards the left, you can see how data sets are loaded onto Google Colab Notebook. And this is slightly different from regular pandas, as Data 8 uses a data science module when importing data. On the right-hand side, you can see a more wordy cell that defines a function and then displays a plot as its output. We'll be going through this lab later on in this presentation to provide a demonstration of how instructors can use Data 8 course materials on a Google Colab setting. Next slide, please. Here, we have provided a potential workflow for Data 8 on Google Colab for students. First, they would have to retrieve and download the appropriate assignments from the platform. We have provided the necessary code to do this, which we have stored in an initialization notebook that we will show later. Before the start of the course, every student would have to run the code in this notebook, which clones the entire GitHub repository and provide all assignments and course materials. The student can then access these assignments and fill in their answers to the corresponding cells. After that, they can download the completed notebook and submit it to a desired platform. This could be Canvas, Gradescope, or others. And our team has also looked into potential integrations with Google Classroom, but we have not tested the workflow for it yet. It is certainly possible to manage a Data 8 course on a Google Classroom setting, and we will look into that in the future if our adopters request a Google Classroom version of the Data 8 course. And for each assignment, around a 1-minute initialization is required at the beginning. This is all included in the notebooks, and no other additional code is needed from the instructor or student. The initialization step consists of mounting the Google Drive to access storage and datasets, as well as installing the AutoGrader. And don't worry if none of this makes sense to you now. We will be providing a demo towards the end of this presentation to make sure everything is clear and runs smoothly. Next slide, please. And as mentioned in the previous slide, to make Google Colab with Data 8 materials, we had to include initialization steps. So the top left screenshot shows the notebook, which is first mounts the Google Drive to the Google Colab notebook, and then clones the entire GitHub repository. And instructors can change the root path of where the drive is mounted according to their preferences. The lower left screenshot shows the initialization step before each assignment. It consists of installing an AutoGrader and mounting the drive again. And since the entire GitHub repository is now already cloned onto Google Drive, we just have to navigate to the correct path. And this is extracted from Lab 9, so the initialization step requires us to navigate to Lab 9 folder correspondingly. As for the screenshot on the right, it shows how our AutoGrader works. If the code passes the test, a short message will appear and tell you that the test has passed. If not, the grader will tell you what the expected answer should be and where an error occurred. Now, I will pass the time back to Amal to explain to us how we use Deepnote to provide other online versions of the Data 8 course.
Justin. Also, just a really quick note on Google Colab. It's really helpful, and we know that it works because we've actually spoken with a few different adopters at the K-12 level that have used Google Colab for their classes. And so they found it to be really, really easy to work with. And once you get it all set up, and it really makes the coding experience for students really friendly. Deepnote, now moving over to Deepnote. Deepnote is also really, really similar to Collab in the sense that it's a cloud-based platform and it allows for collaboration. And we found that it also works really, really well with Data 8, especially with the auto grading system. Also, like if you want to ask questions, we have Alan in the chat here. He's a data scientist from Deepnote. Thanks, Alan. So Deepnote, the entire premise of Deepnote is making data science softwares as collaborative as possible. And so just like Collab, you can work with Jupyter Notebooks, Jupyter Notebook-like environments in the cloud as well, and you're able to work with other students at the same time. This allows for really convenient sharing, and it allows for what we have found to be really helpful at the educational level, especially when students are working on group projects together or when they're working on assignments together. We've also, and the Deepnote also has its own Git tool, their own CLI, and their own assignment distribution as well, which is really helpful at the education level. And Deepnote has had, every single year, they have more universities and more institutions that are using them as a product. And so many Berkeley students, for example, use Deepnote on the side when they're working on their own personal projects, and even other universities have started to adopt them as well within their courses. Best part is it's free for education, and so that is all in the spirit of democratizing access to education. If you look at the top right screenshot as well, you can see that two of the different cells are highlighted in different colors. That just shows how that allows you to see the other users that are on there. Again, similar to Google Drive or Google Docs, Google Colab, where you can see other users on the platform as well. So there are definitely a few features that we found in our use cases and from our own experiences that are really helpful from Deepnote and really separate them from other cloud-based platforms as well. One is there's true real-time collaboration. So that allows students to work together on projects, but really when it comes to office hours, and for context, like office hours is when it's like the tutoring session where like either professors or the GSIs or the TAs, the course helpers, they meet with students after lecture through dedicated time, and they are able to answer questions. So traditionally in many coding classes, what would happen is where you have to, the student has their own laptop and the instructor has their own laptop, and they're trying to debug on one computer and trying to see if it works on the other computer. But Deepnote's able to solve that because you're working directly in the cloud, and so you don't necessarily have have to have two different devices trying to work on the same thing. The second is that you're able to easily send your work from one person to another. That's really helpful. What we found when you're trying to submit assignments, traditionally what the workflow would be is where you're working on, let's say, a Jupyter notebook, you have to download it as a PDF, or you have to download it as a Python notebook, and then you have to upload it through Gradescope, or through some other LMS. Rather, Deepnote allows us to just get the link of the project and send it directly there. That just removes one extra step of having to download a file. The third is where there's a customizable environment. You only have to install the environment once. So like once you pip install something, you don't necessarily have to do it again. That's really helpful when you're working on more advanced machine learning projects as well. There's also NB-Git puller style links and GitHub integration. So NB-Git puller links are where if you have a repo, you can create a link to that repo and get that. And that link allows you to view the notebook as a notebook versus just as a GitHub screen. And we found that again is really helpful when it comes to collaboration. So this is a screenshot of how the platform looks like, specifically when we're looking at the Data 8 course materials, and we'll go over this in more detail, like live in the demo later in the presentation. But as you can see towards the left, you have this, you have like the repo that's cloned, and then there are tabs which you can filter through homeworks, projects, or labs, however your course is structured as. Then if you go under homework 2, for example, you see that there are different tests. These are like the auto grading tests, as well as there's the other files. So like you can see the live file directory. And then towards the middle, you see that the structure is really similar to Jupyter notebooks. Similarly, we talked about Canvas earlier, and so there's integrations of working directly with Canvas, where you can create different labs and create your course content there. You can have your assignment there, and then you can ask students to submit it directly there as well. We found that Canvas works well with Google Drive and specifically Google Colab. There's like an integration between the two. And Canvas's LMS is also really helpful because it's already what many students see in other classes, and so it's not where they have to get used to a new software. Rather, it's already within their student workflow, and it just makes the student process a lot easier. There's also, and going to the Data 8 website, you can also create websites really easily. You don't necessarily have to create a website from scratch, like build it from ground up. Rather, you can use these different templates from GitHub or Google sites to be able to create charts, have links from there to your Deepnote notebook, to your Google Colab notebook, to your Jupyter Hub notebook, to your 2i2c notebook, anything like that. We found that that really helps us and really helps instructors save time because it's easy to work with, and they can redistribute their time away from presenting information like this to other things like creating course content or other administrative tasks. So we will now go over the demos, and we will talk about Google Colab and Deepnote. And then there are also like the specific GitHub repo that we're looking at is here. It's data8.org/materials sp20 external. So I'll now turn it over to Justin, who let me stop sharing this screen real quick, and then let me share that new screen. So give me 1 second.
I think I can just share it. I can just share it while I like run through it.
Sounds good.
So yeah, so we have the link to our demo website right here, which I'm just gonna post it in the chat. So like feel free to follow along as we run through the demo itself. So I'm just gonna go ahead and share my screen really quickly. Okay, cool. Wait, sorry, tabs, cool. All right. So if you guys can't see my screen, is everything okay here? Okay, cool, awesome. So on my screen, we have this our demo website. So this is as of course for demonstration purposes only. It is not perfect yet, so we're still trying to do whatever we can to improve this and make sure everything is running smoothly. So here, please navigate down to Lab 9, and which is going to be this link right here. And remember to click on the Google Colab version of our data in the cloud, as we call it. So we just click on it. It will direct us to this Google Colab link, which, as I said, this is going to be our initialization step. But before we actually do this, we would have to run the initialization notebook, which is going to be this one right here. And Eric, I'm also just going to share this in the chat so then everyone can follow along. Wait. Sorry, guys, just give me a second. I think it's lagging. Okay, awesome. So it's going to be right here. All right, so this is what I call the initialization notebook. And what this does is it basically clones the entire GitHub repository to your own Google Drive. So then you don't have to clone it every single time while you're trying to access the Google Colab version of the Data 8 course. So now I'm just going to go ahead and, yeah, so Carlos, I'm going to go through the authorization code in just a minute. So just let me reshare my screen right here. Cool. So on this page, we have the authorization notebook. So let's go ahead and run this. And yeah, it just gives you a warning. And in this case, just give it like 20 seconds to run. And yeah, so what we have to do in this case is there is this URL in this browser. So we just have to click it. And what it does is you got to sign into the right Google account or the account that you want to mount the GitHub repository to. So I'm just going to press allow. And then this will give you an authorization code, which you can just copy and then paste it back into this cell. And then it would then start mounting our GitHub repository to your own Google account. Yeah, and in this case, it doesn't work for me because I've already mounted it in the past, but then it should be working for you guys if you haven't mounted this GitHub repository to your Google Drive account yet. So please let me know if there's any difficulties or questions up to this point.
So
All
basically,
right, awesome.
One thing to think about with Collab, right, is Collab doesn't when you first go to Collab, it doesn't really give you that like link to a persistent file tree. Like it just starts a session, you can work in a session. So it's a big thing to think about as a teacher. We can distribute things to Collab, students can work in them, they can download stuff, but or it will just go into this folder that's like a Collab notebooks folder. But what we're trying to do is make like a link to like somewhere in our Google Drive where we're going to put all these files. The reason we want to think about this as instructors is there's the data sets, there's the tests. Like it's not just the notebooks, right? We're sending a bunch of stuff. If you're in this initialization notebook, it's just one cell. You run that one cell, you'll see a link that's the link to your account. You hit that account link, tell them which Google Drive you want to authenticate to, and then you'll get a code and you'll copy and paste that code back into the cell.
Yeah, and I guess we're just gonna give everyone like another minute or so to make sure everything works for this initialization notebook before we move on to the lab.
And then, this git clone step is something that we've already done today when we were in the demo notebooks. if you're not finding the Lab 9 notebook, you may not have it mounted in the right place. And the authorization code comes from clicking the link that says auth.
Do we need to share the lab itself, like Lab 09? I think the reason why this is happening is
always because this does not have. Let me look at it.
the authorization code. When you fill out or when you shift enter the cell that has the initialization, it'll give you a link right before it asks for the authorization code. If you click on that, it'll ask you which Google account do you want to sync it with. That's basically saying like which one of your Gmail accounts do you want it to be authorized to use, and then you click whichever account you want, and then after that it'll give you a code. You click the rectangular button to the right to copy it, and then that's your code that you then put in.
What are we doing? Lab 9?
Yeah, Lab 9.
Yeah, so if you're seeing if you're seeing the drives already mounted, that means that it's already synced with.
Mm-hmm. And yeah, Ricardo, you can create Jupyter notebooks and then just upload them into Google Colab. Works the same way.
Yeah.
Awesome. And then I guess we can get started with our demo right now. So let me just reshare my screen. Cool. All right, so we have Lab 9 here, and it is in the web that we have created. So run this. Yeah, and it's installing Otter here, and it sets. So here we have to authorize once again, and it's pretty similar to what we did in the initialization notebook. And we click on this link again, click on the account that you just mounted your Google Drive to, and click allow, and it will again give you this authorization code, and then you just copy, and then you put it back right here. Give it.
So yeah, hopefully someday we'll get Otter installed on oh no, the issue here is we need the old version of Otter to be installed. We'll work on that with the Collab folks directly.
Awesome, yeah. So here we have sort of navigated to Lab 9, and then we gotta initialize Otter to create our grader. And all right, cool. So again, I'm gonna just pause here for a few minutes to make sure everything runs smoothly for everyone. Yeah, and please let us know if there are any questions or difficulties.
So So where is Lab 9? How do we explain where Lab 9 is?
For Lab 9, if you click on the website,
here, can we just post it in directly?
Yeah, I'll try to do that right now.
Here, let me paste it in.
Okay, cool.
Yep. But if you looked at the course website and then go under Collab, which is towards the right column, and then click on Lab 9 there, that's how you could get there using the course website.
The initialization notebook doesn't take you anywhere. It just does that first mounting. Then you go to Lab 9 and you do it again.
Yeah, the initialization demo was to show like how we're getting the files from GitHub and mounting them into your local drive.
Yeah, so you can think of it as the initialization notebook copies the entire GitHub repository to our Google Drive and also to a Google Drive. And then Lab 9, the initialization code in Lab 9 sort of navigates to the right path in that GitHub repository that we just cloned to make sure all the CSVs or of data sets, our images are in the correct location. So then our lab runs smoothly in this case, yeah. Awesome. So I think there shouldn't be any questions. If there are any questions, please feel free to just let us know.
People aren't getting the read Old Faithful.
Okay,
the
so
CSV is not reading in.
All right, just let me go ahead.
It worked for me. So why would the CSV is not ending up in the right place? Or else they didn't mount the drive. Because if you can have Lab 9 notebook but not have the affiliated files.
Yeah.
Maybe try remounting it.
Yeah, you got to do that part in the beginning. That's the mounting.
Yeah. So yeah, you still got to run this cell and also the greater cell, even after you have completed the initialization notebook, because this just clones the entire GitHub repository, but this cell sort of navigates to the right Lab 9 path. No faithful.csv. That is interesting.
So you can look at in the file server for Colab where you say G drive, my drive, Colab notebooks, Colab data 8. If you're seeing that, Justin, can you try hitting, or I don't know, try hitting try hitting the files on the left, the little file folder.
Sure.
Then you go G drive, my drive,
then it should be
Colab
here.
notebooks, Colab data 8.
Collab data 8.
Yeah.
And then it should be
Lab.
That's
where you would find it.
Lab 9, and then it should be right here.
Did everyone mount it twice? Mount the initial one and then run Lab 9 and mount it again? So the initialization notebook brings everything in once for the whole class. The second time that you run Lab 9 is that you ran it and just mounted it just for this file. So I don't know if that was clear or not. Yeah, you had to do that like mounting step twice. One that sets up the
Yeah.
whole class, and then that ones and goes and sets up Lab 9. Yeah, Ricardo, I'm worried that the first mounting didn't work. But the key is you should be able to find this stuff in your G drive now that Justin's showing. We might just have to move on. I'm sorry that we're not keeping everyone with us. Some people are making it through and some aren't, but I also want to have 10 minutes to show the Deepnote as well.
Yeah, okay. So yeah, as Eric said, you might have to remount it again and make sure to run both the initialization notebook and the mounting cell at the beginning of our Lab 9 notebook file. So yeah, and again, if this doesn't work for you right now, feel free to explore it yourself after this demo, because again, we have run this multiple times and using a few accounts, and it should work, but it might need like just a bit more work, or you might have to remount it again. Awesome. So now just let me finish this demo in the next 3 minutes or so. So again, this lab, we're just trying to show you how we implemented the Data 8 version of the lab in Google Colab. So then we're not going to run every single cell, but again, yeah, we just want to show you some of the functionalities and how Google Colab sort of outputs code. And in this case, it's like pretty similar to what a Jupyter notebook would show. So in this case, if we want to plot a scatter plot, we can just input a quick line of code. It's going to be duration and weight. Yeah, and again, it should run smoothly because the data is already loaded into the notebook. And so just feel free to follow along. And then here we're trying to calculate the correlation coefficient. So again, here we have provided these links. So for example, if the students just want to have a quick recap before they actually attempt the question, or while they're attempting the question and they forget what, let's say, how the standard deviation is calculated or what the standard units are, they can just click on the links that are included in this notebook to just navigate to the right location. And then here we're talking about standard units. So then here's the formula for standard units, and they can just input everything from this formula to get the correct answer. And the grader, it would say grader passed if you got the correct answer. So let me do a quick demo right here. So we want to calculate the mean of the duration column. So it's going to be duration. And then here let me just copy and paste. So here we want to do the standard deviation. So it's going to be np.std. And then here is going to be the mean of the weight. And here's going to be the standard deviation of the weight as well. And here, just let me finish this quick question, and then we can move on. And then here as we looked here, the standard units is going to be the value minus the average divided by the SD. So we can just go ahead and do the same. Divided by the SD.
Live coding.
Yeah. Weight, and then here it's going to be weight as well. All right, so now we have the entire thing in standard units, and then the grader check. So for labs, it actually checks for correctness. So for labs, if you actually pass the test, that means your code is basically correct and there are no errors, so you can move on to the next part. But this would not be the same case for homeworks, which Amal will go through later. because it only checks for that your answer makes sense. So for example, your answer gives like a string instead of a number in that case. So so I'm just gonna skip through all of these for the sake of time. But then towards the end, here is gonna be a greater all cell. So after you finish all of your questions, the greater, you can just run this greater.check all cell, and then it basically runs all the greater checks again. So in this case, we basically just completed the first question. So it's going to say question 1, part 3, test pass, but then all the other ones, because we haven't attempted it. So it's going to say, oh, you haven't attempted it, so the test failed. And it is expecting correlation equals to 3 in this case, and 3 in this case is not the correlation coefficient R, but it's going to be a multiple choice that is labeled 3. So in this case, yeah, I'm just going to fail all of these tests because we did not attempt it. And then towards the end, here's going to be the export cell, where again, you can just run it and it will generate a PDF for you to submit to Gradescope or Canvas or any other platform that the instructor desires. Yeah. And sorry that I have to go through that in such a rush, but I also want to save some time for Deepnote. So now I'm going to pass the time to Amal to do his demo on Deepnote.
Great, thank you, Justin. So also, Justin, if you don't mind, could you please put the link to the Deepnote in the chat? For some reason, it's not letting me type in the chat, so I can't put it.
Sure.
Here, I got it. Oh yeah, you got it? I don't have it.
It's the last slide of the presentation. Yeah, I think Justin has it.
I posted it in the...
Thanks, Justin. So Deepnote allows us, like through this link, if you click on it, it should lead to the page that I'm sharing on my screen. So what it does is it's cloning the repo and then allows us to view the code in the repo through the cloud-like environment. And so what we see here, if you don't have a Deepnote Deepnote account, you could just view my screen. If you do, then you would be able to look at it directly. So if you look towards the top left, there you can see the file directory, notebooks and files. So that's where we're seeing like demo, homework, lab, projects, etc. So for right now, we'll just look at a specific homework, and we'll look at homework 9. So we go down to homework 9, and then we see that these are all the files that are relevant to homework 9. We have our tests, we have the CSVs, whatever images needed, and then our actual notebook. Now, when we have our notebook, when we click on it, at the top, it'll say setting up environment and then ready. This might, based off of your Wi-Fi speed, this might take a little bit longer, might take up to 30 seconds on your first time. And so you could just run the notebook, like run all the cells in the notebook, but what we'll do is we'll just go cell by cell. And what you'll notice here is that we're just directly importing Otter. And so we don't have to specifically get a specific version of Otter, because as we did in Collab, because with Collab, Collab's, at least up till recently, it's only available up to Python 3.6.9, and the latest version of Otter Grader uses Python, like a Python version that's more advanced than that. But Deepnote has more recent Python than that, so we don't have to have a specific version of Otter. So when we and then again, it's just like a Jupyter notebook, so you just do Shift Enter, and you can see that it's initialized the grader, and then towards the left, Otter log. That's how you know for sure that Otter's been initialized. So we'll go through this. We see that we can import, we can import our libraries, and this lab is about. Oh wow. Okay. Well, I chose a different homework, but this lab is about. This homework's about the Air Force and warplanes, and so when we can come down here and we can choose to input information to answer the question. So specifically, it's asking for N and N estimate. I'm just going to get the answer directly, and what we can do is, if you try putting in some other answer, let's say the answer is like 5 or 4, and then I say an estimate is 5, and then you try running with the autograder, you'll see that it fails. And that's because it's looking for an answer that's closer to the hidden tests. But if we put in like what the right answer is actually, it's a string. It's not even an integer. So there's a parameter and then there's a statistic. And then if we do that, then we'll see that the grader should pass. And then it says grader passed. So just like that, like we would go through all of the questions and answer it. And Deepnote allows us to basically like have the collaborative features. So for example, if we were to share this link to someone else and they were looking at this notebook, then you would see where in the notebook there are, and you could like edit code directly together. The final step is that you can export your answers. And so similar to Colab, you do Shift Enter, and then in your file path down here, homework 9, it gives you the date and time. That's so you know which one's most recent. You can directly download that, unzip it, and then download that, and then you can submit that. So with that being said, I'll leave the remaining 2-3 minutes for questions. If you have any questions about Colab, about Deepnote, about any of the other platforms that we talked about, please ask them in the chat. So Brian,
go ahead. Sorry, Amal.
Go ahead.
Okay, so first, Ricardo, I think during our multiple tests we haven't faced this problem yet, and we will definitely like look into that and reach out to you about like the solutions to that, because I think according to our test, like I don't think that happened before, but we'll definitely look into that and see if there's anything that we missed in the process of setting up the Google Colab, and we're sorry about that. And as for Laura, any way to do this without mounting your Google Drive? Okay, so another way that we did it before is we we cloned the GitHub repository and then just navigate it using the file path on GitHub. But then we found that not to be a good idea, because that, for example, if we change files on GitHub, it would not be changed on the Google Colab, and it would just be a mess. So for example, if the instructor wants to update a particular lab or a homework, it would not be directly reflected on the Google Drive. But in this case, if we mount the entire thing, the Google Drive will be updated as you change the GitHub. So we think this would be a better idea, but we're sorry that this did not work for some of you guys today. And yeah, Amal, do you want to take on some of the questions?
Yeah, regarding the Deepnote ones, I think like in the beginning, your first time, it might take a little bit of time. But then once you like have an account and you initialize like frequently, it takes a lot less time. And then Alan's also saying in the chat that Deepnote's free for educators, researchers, and students. If you have like questions directly about like using Deepnote in the institutional level, like please reach out to Alan, but also let us know if you are doing that. So we would like to know which different softwares that different educators are using.
Thanks, you guys. Tough to figure out exactly what happened, but I think, for me, it's a good illustration that lots of people are like, hey, use Colab, it's free and easy. But, we've been fiddling this for a while, and like you fiddle with this thing or you fiddle with another thing. There's a flow to everything. I think it's like, it's sort of like there's a bunch of files involved. And they all need to come in at the same time. but we'll keep iterating and trying it out. We're just trying to make multiple pathways available for multiple people. We definitely just was like, what would it be like to do it in this platform or that platform? And these are not exclusive. These are not recommendations or endorsements or exclusive number of options. Like there's a couple other vendors that are coming that'll have expo booths. There's definitely like open source ways to do things that have no vendor involved. There's some vendors that do a super nice job with this. What Microsoft's doing keeps evolving. Like there's a lot of evolution going on in the space, and there's a lot of different ways to get this done. But we just wanted to illustrate, basically illustrating using like the same base set of notebooks, what it would look like and feel like and deploy like in different platforms was what we were sort of going for with this talk. So thanks for bearing with us and being patient with us.
Thanks for attending the session, y'all. If you have any questions, please email us directly at ds-help@berkeley.edu. But yeah, dinner time, especially for those on the East Coast. It's like